So we've used numbers and exponents previously. Let's do a quick review. Say we have 4 squared. The 4 is the base number. The 2 is the exponent or the power. And it means that we're going to multiply 4 to itself 2 times. So 4 times 4 is going to give us 16. Now 16 is considered the square of 4. So 16 is the square of 4 in this case. You could also write it as n squared equals m, where m is the square of n. If you think of an area problem where we have 4 rows and 4 columns, and we want to find the area, we know the formula is side squared. So 4 squared will give us 16. So the area is similar to the square of that number, similar to this situation here, 16. Okay, now sometimes we're going to get perfect squares, and let's think about that. Perfect squares are squares that are whole numbers. So if I square 1, I'm going to get 1. If I square 2, I'm going to get 4. 3 squared is 9, and so on. These numbers here, the squares, are whole numbers, so they are perfect squares. There's a chart in the textbook with several other perfect squares you might want to look at. Now you can take the square of a negative number. Negative 3 squared is going to give us a positive 9. And that's because when we multiply 2 negatives, we're going to get a positive. Now, if I were to take the square of 3, again, that's 3 times 3. That's also going to give me 9. So 9 is the square of both a positive 3 and a negative 3. Let's do that for 5. 5 squared and negative 5 squared is going to both result in a positive 25. 5 times 5 is 25. Negative 5 times negative 5 is also 25. So the square of a number, can be gotten through a positive number and a negative number. Now the inverse of a square is finding a square root. I've talked about inverse operations before in Math 1. Subtraction is the inverse operation of addition. Division is the inverse operation of multiplication. And so the inverse operation of squaring, so an exponent squared, is going to be taking the square root. Now this symbol is called a radical. Oops. The number that's inside, say 16. That's called a radicand. Okay, now with a square root, we can find the square, the squared number. So if we have the square root of 25, our answer is going to be 5. And that's because 5 squared equals 25. If we do the square root of 36, my answer is 6 because 6 squared equals 36. And one more, if I have 100, my answer is 10 because 10 squared equals 100. Notice that my answer is the base of my numbers being squared. And notice that I'm not writing 5 times 5. I'm just writing the base number. Okay, these are the numbers that are being squared to get the 25, the 36, or the 100. Now, because a number like 100 has both a positive square and a negative square, we can show that negative by putting a negative sign in front of the radical sign. Okay, so now this becomes a negative 5, a negative 6, and a negative 10. And let me show you how that is. When we're solving or simplifying, you can think of this radical sign as similar to a grouping symbol, like a parentheses. And we're going to simplify this first. So the square root of 25 is 5. Now we are going to deal with this negative. So we need to bring that in, and that's where we get the negative 5. So the square root of 36 is 6, but then we have that negative on the outside, and we get negative 6. 10, and then negative 10. So the 36, the 100, has both a positive. One thing to keep in mind is that when we are taking the square root of a number, like positive number, we're going to get a positive answer. So in this case, it will be 3. Now, it will be different if we have a negative on the outside of that radical sign. In this case, we'll get a negative 3, similar to what we talked about earlier. The issue that I want to focus on just briefly is that you cannot take the square root of a negative number. In this case, the answer is not a real number. Now, if you take more math, you'll look at these types of numbers. But remember, we're working with real numbers. That includes natural numbers, whole numbers, integers, and rational numbers, as well as irrational numbers. There are other types of numbers, but we're just focusing on real numbers this quarter. And negative root.